All right, so these are the last type of equations. There's nothing special. Well, there's a lot of special here, but there's nothing new. They're just weird, and some require tricks, some are just different. So I just want to throw a bunch of combined everything together. So if you look at this equation, you see that we have sine of 2x, and one of the tricks is always to rewrite tangent in terms of cosine and sine, like this. But if I multiply both sides by cosine, that's going to have stuff when cosine is equal to 0, and we could be eliminating it. If I divide by sine of 2x, same thing. So we really want to result to what we've been dealing with is treating these as with factoring and linear and stuff. So the trick is this. If you see that they both have a sign on each side, you can split them up like this. This is still the same thing. And then you now bring that one over. Now we have a common factor. So if we go 0 equals and we factor out that sine of 2x, we get this. And so now we can say sine of 2x equals 0, and 2 over cosine x minus 1 equals 0. Solving this, multiplying, we get 2 equals cosine x. And we know that cosine cannot equal 2. So what this did is allow us to take tangent, convert it to sine and cosine, and by factoring we were able to eliminate our cosine. So now all we have to deal with is sine of 2x is equal to 0. And so sine is equal to 0 here at 2 pi, and then it's also back again at pi. So from 0, pi, and 2 pi, that's what we have. And remember, we're going to have this repeats every pi. So if you go through this and you say, well, 2x, let me change the color, 2x equals 0 and 2x equals pi, and then we're going to put plus 2 pi k plus 2 pi. It's too much. So it's better if you notice that it repeats every pi to just say x equals 0 plus pi k. Now, this is our answer for all of the solutions, but they're also now going to ask you for stuff as well with double angles and half angles, where they want it to be between 0 and 2 pi. So by having this formula, we can now plug it in and find all of the solutions we want. So our first one is 0. Where's the next one going to be? Well, this is supposed to be 2x. So we have to divide everything still by 2. And so we get x equals 0 plus pi over 2k. So it's 0, and then pi over 2 is the next one. Still within 0 and 2 pi, perfect. And so we're going to add pi over 2, so pi, and then another pi, and then another pi, and then we're done. That's 0 to 2 pi. So as long as we're within there. And again, we plug this into Desmos, and we check. So 0, pi over 2, pi, 2 pi. So those two are equal on those points. And there are all our angles, 0, 2 pi, pi over 2, pi, 3 pi over 2, and 2 pi. So that's a trick. Convert it to sine and cosine, and then you factor out the sine whenever you see it. All right, the next one is just dealing with a 3 divided by 3. It's not a half angle, it is a third angle. So we treat this the same way. We say that that's a, so a is sine of x over 3, just to make it look nicer. And then we end up with 2a, because that's sine, plus radical 3 equals 0. And we can solve. So a quick solve, and we get negative radical 3 over 2. And then we throw our sine back in. And it works the same idea, radical 3 over 2. So we go to our unit circle. So negative radical 3 over 2 for sine would be right here. So 4 pi over 3 and 5 pi over 3. So x over 3 equals 4 pi over 3. And x over 3 equals 5 pi over 3. Now these are not a pi away, so we do have to treat each one. So we have 4 pi over 3. It's not pi away, and it's not even. So I can't go, oh, well, that one plus that amount plus, yeah, it's not going to work. So we have 4 pi over 3 gives us negative radical 3 over 2, and 5 pi over 3 equals negative radical. So then we have this plus 2 pi k plus 2 pi k. And so now to get rid of the 3, we're going to multiply everything by 3. So remember, this is tripling. It's going to happen 3 times as slow, so the period is 3 times as large. And checking in Desmos, you can see it's 4 pi and 5 pi. And this is being shifted by 6 pi k. So 4 pi, 5 pi, right there, 10. So 4 plus 10, 4 plus 6 is 10, and 5 plus 6 is 11, and then going the other way, 4 minus 6 is the negative pi. Oh, sorry, right there. There we go, negative 2 pi, and then 5 minus 6 is negative pi. So everything's checking out perfect. These are our answers, and they're not going to ask you on this one. You don't really see it between with a third and between 0 and 2 pi. If it is, they're specially made because they're not going to be. You're tripling it, so it's going to be massive. All right, this is our next one. This is my favorite. This is just a special trick. So what you can do is square both sides. By squaring it, we get a Pythagorean identity. So if we take this sine and we put a sine on one side and move the cosine to the other, and then we square both sides, we end up with sine squared x equals, and on the other side that's a little FOIL, so we get 1 plus 2 cosine x plus cosine squared x. And the reason I moved the cosine is it's minus, so by moving it over it would turn into a positive. It makes it a lot nicer. And then, so the reason to do this is we want to make all the sine and cosine the same, but it's kind of hard when they're just sine and cosine, right? So if we square it, we can then turn this into 1 minus cosine squared x and we end up with this. So now we can move everything over and use quadratic formula or factoring. And since that becomes a minus 1, we already know we're good. We don't have to use quadratic formula. So we end up with 0 equals 2 cosine x plus 2 cosine squared x. And then now we can divide everything by 2. I'm going to put the squared x first now. And we can factor. So it's a cool little trick. By squaring both sides, it allows us to convert our sine squared into 1 minus cosine squared. And there we go. So now we have cosine x equals 0 and cosine x plus 1 equals 0. So cosine x equals negative 1. So if we look at our unit circle, cosine will be negative 1 here at pi, and it will be 0 at pi over 2 and 3 pi over 2. So this one would be x equals pi, and this one equals right here, pi over 2 and 3 pi over 2. So here's the problem now. When you square things, you are getting positives and negatives. So there's a lot. If you look at your unit circle, let's assume that they're the same. Right here, sine and cosine are the same, right? So if you were to square them, these would also be the same, and these would be the same, and these would be because a positive and a negative, when you square the negative, it turns into a positive. Now we do have a 1 in there, but it's the same basic idea. So that means not all of these are actual solutions. I mean, they could be, but most likely they're not. So what we're going to do first is find out which ones they are, and then the ones that are the correct answers, we will add plus pi k. And so that's why I had to split them here. You would see that it is pi over 2 and 3 pi over 2, and so you just want to do this plus pi. But you really have to split them in this one. These two have to be split, and you have to check each one. So the quickest way to do is to pull up Desmos, but you can just plug them in the calculator. So plugging them in the graphing calculator, you can see that that equals 1, negative 1, and 1. So when we look here, we need it to equal 1. So this is a false solution, and it's because it's making negative 1. If you square negative 1, it becomes positive, right? So we cross that one off, or let's just erase it. These are our two answers, and so now we just have to add on to it 2 pi k for all solutions. And if it wasn't all solutions, then we would be good. And then we check in Desmos just to verify it as well. So our sine x minus cosine x is equal to it at pi over 2 pi, and then again 2 pi away. So pi over 2 plus 2 pi is 5 pi over 2. And then pi plus 2 pi is 3 pi. Solutions work perfectly. All right, the next one is just a quick little factoring one, but it has a special twist to it. So again, we replace the sign x with a, and then we factor like that. So we get minus 6 minus 1 is 7 plus 2. And then we say 3a minus 1 equals 0. A minus 2 equals 0. So a equals 2 and a equals 1/3. And then we plug our sign back in. So you can see why this one has a special twist. What's wrong with this one? That's right. Sign cannot go above 1. So that one's out. So all we have to do now is worry about a third. And there is no third on the unit circle. So there's no exact answer. So we have to say x equals inverse sine of 1/3. And this is going to give us 2 answers. Only one with the calculator, but 2 overall. So again, let's change it to degrees, because degrees are easier to use with these. Second quit. And then we do inverse sine of 1/3. Right? It's in degrees, so now it will spit out a positive degrees in the first quadrant, which is 19.47. So our x equals 19.47 degrees plus 360 degrees k. That's all of them. But we do have a second one. So if you remember, sine is positive in quadrant 1, and that's 19.47 degrees. It's also positive in quadrant 2. So that would also be 19.747 degrees. So we need to subtract 180 degrees from it. Not 108. 180 degrees minus 19.47 degrees. So we have to find the other angle that is positive. So it's 180, take away 19.7 would give us that one. So 180 minus 9, I know you can do this in your head. 19.47 is 160.53 plus 360 degrees K. Okay, and you should check these by plugging the 19.47 into this equation, verify it does 0, and then that one as well. But Desmos works great as well. So I've already plugged it in. I then went over here and changed it to degrees and moved it to 360 so it'll show up, because if you have it before, it was only at 2 pi, which is not that far. So there's the equation, and we want to know when it equals 0. So that's the x-axis. So we have those 2 points, 19.471 and 160.529. There they are. And again, it's going to repeat every 360 pi. So you could see 19.47 plus 360 is 379, and then it'll go in the reverse as well by subtracting. So there you go. These are all the special ones. I hope. So if you get stuck, just look here. There's tiny little tricks. Just remember, if you are going to square both sides, completely legal, just you have to check your answers, because you will introduce false solutions.